If you want to know how an ABG machine measures how much oxygen is in your blood sample, then you need to know about the Clark electrode. This is a really cool piece of kit, and I'll show you how it works. So you start with your blood sample, and then you have a semi-permeable membrane. Oxygen can cross that semi-permeable membrane into your testing chamber, which is full of a buffer. This will come as no surprise from our previous electrodes, and it's full of potassium chloride buffer. Then we're going to throw in 2 electrodes. This one is silver chloride, which you'll remember from the Severinghaus and the pH electrodes, and this one is a platinum cathode. Now, what we want to do is generate some sort of current or voltage which will change depending on how much oxygen is here, because that way we can just calibrate it, and then any change in current we can deduce how much oxygen must be in the sample. Now, whereas with the pH electrode and the Severinghaus electrode, we built up a differential of electrons across a glass membrane, for the Clark electrode, we're going to generate a current. And instead of measuring voltage, we're going to measure current. So to do this, we need an ammeter, which is going to tell us how many amps or milliamps of current we have. And we also need a power source, which is going to help drive that current round. And this is a 0.6 volt power source. Can be battery or other power source, but it's generating 0.6 volts. You need to know that for the exam. And if they ask what are the downsides of a Clark electrode, one of the ones you can list is it needs a power source, which is slightly more faff than not needing a power source. So this battery or power source is going to push electrons down towards our platinum cathode, and they are all going to collect at this end. What we need is some way of completing this circuit such that this current can flow. We could try and bridge electrons across to this side of the circuit, or we can just remove electrons here and supply electrons here, and that has the same effect as connecting the circuit. What the oxygen molecule is going to do is it's going to help remove electrons from here, and what the buffer is going to do is help supply electrons here, and that way we end up with what behaves like a complete circuit. So the reaction at the platinum cathode is an oxygen molecule mops up 4 electrons and then combines with 2 water molecules, and that ends up making 4 hydroxide ions. So every molecule of oxygen will mop up 4 electrons from the cathode. So you can already see how this system is going to change depending on the oxygen tension. If there's more oxygen, you're going to mop up more of these electrons. You're going to get a bigger current. Meanwhile, at this end, you've got this very simple reaction of silver plus chloride goes to silver chloride, and then that also releases an electron. You need the chloride to come from the buffer. The silver comes from the electrode itself. This is why it's a silver chloride electrode, because you end up producing silver chloride. So at any given time, assuming this has had some use, some of this is going to be silver chloride. And then you can see that you are producing electrons, which can then be supplied to flow around the circuit. And the changing parameter is the oxygen tension. More oxygen, more electron removal, faster current, and therefore you can measure and work out based on the change in current what the oxygen tension is. And if you want to get really pernickety about the details, technically this is a chloride ion. So that's how these charges balance out. If you're worried about where that extra electron came from, it's because this is in solution. This is a chloride ion which has got an extra electron which is released when the silver reacts with the chloride. And that's how it all balances out. And today's featured blend is macchiato, specialty coffee for the anaesthetist, only available to members of anesthesia.com.